This question is the application of Newton's second law, because in this question we will see that the object will accelerate on the rough surface as described in this question, horizontal rough surface. So let's say this is that rough surface which they are talking about, and the block that is moving on it is this one. So it is accelerating on this rough surface with how much acceleration? This acceleration is 2 meter per second square. So if we double the force from 12 Newton to 24 Newton, that's the applied force. Okay, so this is a direction of the force 12 Newton. And then what will be the acceleration if you double the applied force? So let's quickly draw the free body diagram here. And okay, so when we will draw its free body diagram, so we see that the object, well, the object mass has not changed despite of increasing the applied force. So that's why we will draw the same length of these two arrows, which are in fact describing us, explaining us that the both weight and normal force are equal, and this is a 12 Newton force. All right, and the frictional force, please notice that the frictional force should be less than 12 Newton, and this is in fact a constant quantity. All right, and why is that? Because this is a dynamic friction, which is, you know, that it's a mu d, coefficient of dynamic friction, times the normal force. Okay, so due to the we have not changed the rough surface, that's why the mu d, this factor, this number will not change, and the normal force has also not changed during the increase of force. So if you apply Newton's second law, because of the unbalanced force, we see that the 12 Newton minus frictional force is the resultant force, is the net force, that must be equals to the mass of the object times its acceleration. With the help of this equation, we can certainly find out the frictional force. What is the mass? That is a 4. Acceleration is 2. So 12 minus 8 is equals to the frictional force exerted on this object by the rough surface. So this will not change. So I'm going to draw the same length in this diagram, right? That is 4 Newton. But now this time the force has been doubled. All right, that is 24 Newtons. Whereas, just for a good practice, let's try it once again. These two vectors are same. So now what is the resultant force? You see from the diagram that 24 newtons minus 4 newtons is equals to 4, that is a mass of the block, times acceleration. So that is 20 is equals to 4a, and a is equals to 5 meter per second square. So this is the acceleration due to doubling of the force.